My name is Zach Caseberg. I'm your tutor, your coach, your host, who likes to help to bring you some information about passing the RD exam. And one of my biggest passions is helping RDs and RDs to be to know more about the CDR exam, know more about what's necessary to pass the CDR exam. And my biggest passion for several years has just been helping different students through tutoring, through videos, through working with other resources to help know more about this thing. And so, thank you for joining me tonight. If you wanted to kind of learn a little bit more, my big purpose of doing these YouTube lives is one, keep things nice and accessible for people, make it easy to find. If you never get the chance to join these YouTube lives, remember, you can just go to the RD Exam Ready channel. Subscribe if you want to, but if you go down to live, you can watch these recorded lives at any point whatsoever. So tonight we're dealing with just a little bit of new technology, and new being in quotes a little bit. So it'll be a little clunky, but I think it's going to go much smoother actually than some of our previous sessions. So I'm really excited for that. I'm going to be using my tablet a lot tonight, doing a lot of writing, kind of in real time with you. First things first, just as we're kind of getting into things though, I just wanted to go ahead and just plug a couple things here. So if you haven't yet, make sure you check out the RD Exam Ready podcast. So that's the podcast that I'm doing every week. 20 to 30-minute little episode snippets. Recent one was on FTE, full-time equivalents. So if you enjoy that type of content or you want something just to help supplement your material, check out the RD Exam Ready podcast everywhere where you like to get podcasts. So here's a few of the spots you can do that. And then if you want, just regarding, obviously you found the YouTube page, but if you want, just keep in mind that you can go ahead and check out any of the videos that I've done before. I'm uploading the podcast here too. And then if you want to join the lives, you can do so right in this live area. So either you can see when I'm going live or hear some of the previous ones that we have done before. So make sure you've subscribed to those or make sure you're following just so you can go ahead and see things as we go along. Much appreciated through there. Thanks, folks. All right. All right, good. Like I said, it's going to take a few minutes. So, the reason you're here tonight is because we're going to be talking about enteral and parenteral nutrition calculations. And in particular, it's something I'm so passionate about. And, I'm passionate about almost all topics that have to do with dietetics, but this one in particular is very near and dear to my heart, mainly because I used to work in oncology, and specifically, I just worked with patients with head and neck cancer. So, all I would do all day is just tube feeds, tube feeds, tube feeds, tube feeds. And I really loved it. So that's why I think it would make me a good tutor to go through this concept with you and walk you through. Now, with the chat's on like a 10 to 15-second delay. You're going to use that chat to primarily communicate with me. So use this if you want to ask me a question or if you want to message something. If you'd rather reach out to me later, you can absolutely do that too. But just know if it feels like I'm not jumping in those chats early, it's just because I'm letting stuff load up a little bit. But please definitely use that. Make sure you have your calculator, your scratch paper handy, and we're going to dive in here in just a minute. The way we're going to break down today is we're going to start with Enteral. We're going to go through the very basics of Enteral, just how do we calculate what we need for enteral nutrition. We'll talk about kcals, we'll talk about protein, rates, total volume. Then we'll move that on to parenteral and go through all the steps of that. And then to finish tonight, we're going to be spending time doing practice questions. And I really want to get to those practice questions. So if it feels like I'm flying through a little bit fast, you can tell me to slow down or speed up or anything there. But my goal is that we're going to leave a good 20 minutes at least to do our practice questions tonight. So, Zach, enough talking about it. Let's dive right on in here. Okay. Perfect. So you should see my screen pulled up here. You should see it should say enteral nutrition calculations. If it doesn't, then that's okay. We'll figure it out always. But here's the first thing I wanted to start with. We're going to talk about calories first with enteral nutrition calculations. And I worked up this little kind of little sheet for us here for us to talk about. What I want to emphasize on this sheet is that what we're trying to do here. Oh, okay, you can hardly hear me. That's okay. Let me move this up. That should be a little better and louder for you there. I don't want to blow out anyone's eardrums there. Yes, and Joanne, we will be doing some free water tonight a little bit. Yes, we will. Yes, we will. Hopefully you can hear me a little better, Lorianne. All right. If anyone else has any big audio issues, just tell me and I'll yell and speak up. So with these, what we're going to kind of start by talking about is if I am given the total calories that a patient requires, or let's say I have amount of total calories provided in a tube feeding solution, for instance, we're going to move from left to right to show you how this is going here. So, if I wanted to take my calories and I wanted to find out the total volume, I'm huge on finding the total volume when it comes to enteral nutrition calculations. What you would do in that case is I would take my total calories and I would divide by the concentration of that tube feeding formula. So, let's say it's a 1.2 kcal per milliliter formula. In that case, I would take my total kcals and divide by 1.2 if I wanted to find the total volume. Simple as that. Now, to find the rate from that step, this is the reason I put that total volume in the middle is because you're going to have to find that, folks. So to go from the total volume to the rate, we're going to divide by 24 hours. Now, on the exam, if it doesn't specify, we're going with 24 hours. In real practice, it's more like 22 hours. Sometimes it's 12 hours in different situations. So really on the exam, let's just acknowledge that, hey, only thing we need to focus on is just going to be what we see for 24 hours there. Now let's talk about the other way. Let's say I'm given a question where I'm given the rate, and I want to know how to get myself all the way to kcals. Well, I would take that rate and I would multiply by 24 hours to get the total volume. Then I'm just multiplying by the kcals per milliliter. So we used 1.2 as our example, so I would multiply by 1.2. This is all just to give you a guide to say, here's how I start on one side of the scale and move to the other side. So now let's take a look a little bit. I'm going to zoom in a little closer to make it easy to see. Let's start on the left here. Sorry, I've got a little practice question for us. So let's say our patient is using a 2 kcal per milliliter formula. And let's say they require 2,000 calories per day. So I'm going to start on this left side here. Let's say I just started there. 2,000 calories, and I want to find out how much total volume I would need of the tube feeding formula. Okay. So in that case, you are going to divide, folks. You would divide by the 2 kcals per milliliter. Let me write that there. So divide by 2 kcals per mil. When you are dividing by that 2 kcals per mil, what you are doing, folks, is you are then getting rid of the kcals part of it. And this is good. This is very helpful for tracking your units because this helps to tell you to know, okay, I've divided by kcals per mil, leaving me with only milliliters. Okay. Let me know in the chat if you're all following me pretty well here or if I'm making no sense. Either or will be taken. So then if I have that 1,000 milliliters or whatever that total volume is, this is exactly how I did it every time I worked with a patient was I would then say, okay, I know what my total volume is. I know which formula we're going to use. So then I would finally divide that total volume by 24 to get my rate. So in that case, my rate, if I did 1,000 divided by 24, and I know you're all going to always check me to make sure that I do this correctly, I got about 41.6 mils, and I rounded that up to 42. Okay. So in that example, folks, let me know, does this make sense? And are there questions? We're going to take just about a 20-second pause or so just for questions on that piece right there. Got 8 RDs to be in the chat hanging out here. It's really good to have all of you. Hey, Soph, Laura, great to see you. Joanne, Deborah, hi. Welcome, welcome. Okay. Gonna give it a couple more seconds in the chat. Seems like we're all doing so well so far, though. Okay. All right. Then, as I wait for questions there, I'm going to scroll down and I want to give you this question down here. So take a look at this question that I've given you that's going to be here on the bottom. So this question says, a patient is receiving a 1.2 kcal per milliliter formula at a rate of 56 milliliters per hour. Calculate the total kcals in total volume. Okay. So if you feel ready for it, work on that one on your own, but I'm going to start breaking it down as if I'm with you on exam day so we can go through that. Okay? So in this case, what I would do is I would say, all right, I know I have the rate for this patient, and I know that rate is 56 milliliters per hour. Okay? In order to find that total volume for that, which is what I would recommend doing here, I'm just going to take that 56 milliliters per hour and I'm going to multiply by 24 hours. So now hours are out of there. Hours are crossed out and are no longer in this picture because of that. When I do that multiplication, it's going to give me the total milliliters or the total volume that's provided. So in this case, 1,344 milliliters is how much volume is being provided in this tube feeding formula. Okay. Then I'm going to go ahead and take my next step after I found that. So now that I have found that total volume, I can now use that to go ahead and find out my total kcals. So I'd like to do that together too. You might be way ahead of me already, but I'm going to take that 1,344 milliliters. I'm going to multiply by 1.2 kcal per milliliter. And when I do that, I'm only going to be left with what's on there. So then once I do 1,344 times 1.2, I'm going to end up with a total amount of kcals of about 1,613 kcals. Sorry, that's so messy there. Okay. So this is just the basic way that we should go through each of these enteral nutrition calculations. Just like that every time, with exception, there might be some that are maybe just a touch more challenging or have one more element, but for the most part, this is how I would recommend applying this in practice and during the exam as well. So let's take a quick pause here for 15 or so seconds. Any other questions right now about this one right here? It's quiet out there, which means I know how bright you all are. Good, good. Let's give that just a few more seconds of time. Okay. Seems like we are looking good here. Okay, I will keep an eye on the chat. Now, let's move on to our next phase, which I'm going to talk about how to find the protein, the total protein that is provided in a tube feeding formula. We're going to approach it kind of in a similar way, actually. The way it sets up is very similar because you're just going to start by finding that total volume, okay? So up here, I'm going to have us find our total volume, okay? So total volume is what we're going to have on there. So if I start with a rate, let's say I start with a rate of 50, okay? So let's say we start with a rate of 50 mil per hour. I would want to go ahead and find out the total volume. And then once again, when we have the rate and need to find the total volume, we're going to multiply by 24. So 50 times 24 would get us 1,200 or 1,200 milliliters. That would be your total volume of this particular example for the tube feeding solution. That's all you got to do is just find the total volume every time. That's always going to be really important to do is find that total volume. Good. Very good. Now, here's a big piece that I want you just to pay attention to if you've ever struggled with this. Okay. This part is really difficult for students because I feel like we haven't used a lot of these skills in a while, and that's what makes it challenging. So, the way I should say, pretty much every question that you see on the exam is giving you the amount of protein in the formula, but the way they give it to you is going to be grams per liter. Okay, grams per liter is usually how they give it to you. Grams per milliliter, that'd be like a very small number. So that's why they don't do that. Typically, for tube feeding solutions, they're going to give it grams per liter. The problem students have, though, is they can't remember how do I convert milliliters to liters. And that's what I want to help you with at this step. So I want you to remember milli means 1,000. I know it sounds like a million, but milli means 1,000. Milligram, milliliter, it means 1,000. So if I have a total volume of, let's say, 1,200 milliliters, like we just did, I'm going to go to liters, which is going to be a larger unit. And what I mean by that, it's like a bigger amount, not a bigger number, but more like a bigger like quantity. So what I'll do is, not to confuse you there, we'll do 1,200. We'll divide by 1,000 in that case. And when I divide by 1,000, it's moving that decimal place 1, 2, 3 points over, meaning I'm going to be at 1.2 liters will be the total volume for that amount there. So dividing by 1,000 will get me 1.2 liters in this case. If you have struggled with this piece, please make note. Please note how to do this because it really can be that simple. It's going to help you on so many questions like this, especially if you freeze up during this. This could be the problem right here. So let's make sure we know how to convert milliliters to liters. Then what we're going to do is we're going to take the total volume in liters that we found, and we're going to multiply it by the grams of protein per liter that they gave us in the question. So in this case, let's say I have 1.2 liters, and let's say we're using a 50 gram of protein per liter. So in every 1 liter, it's 50 grams of protein. That's what we're saying right there. 1.2 times 50 would get me a total of 60 grams of protein for this example there. Okay. So again, you're just finding out that total volume in liters. You're multiplying it by that concentration of protein per liter, and that's just giving you the total protein provided in the whole day that they're receiving this tube feeding formula. That's it. That's all you have to do. That's all the hardest work on that one right there. Okay. All right. So let me know in the chat, how are we feeling, RDs to be? Are we feeling good about these? Are we feeling a little bit nervous? Is it getting more confusing? Let me know if you're feeling good. It's easy, it's simple, and we'll be good to move on from this point here because we've got parenteral to go through next, which I love. I love a challenge. It's good. All right. Good. Just still looking out for stuff in the chat. Seems like we're feeling pretty good at this point. Oh, you're all so bright. That's great. Coming along. I like it, Priscilla. Awesome. Good to have you here too. Love it. Okay, so now let's go ahead. Let's do a little practice question here. So down here at the bottom, it's a little bit itty bitty for you here. But what I've got here for you is I've got, let me get my face out of here. I've got a patient is receiving a formula at 50 milliliters per hour using a formula that is 60 grams per liter. So I'm going to write those down so I don't get confused because, that happens to me too. So let's do 50 mils per hour is the rate. And I'm going to go ahead and I'm going to get my total volume. Okay, so times 24 hours, 50. Zach, you just did that. You should know that, but it's going to be 1,200 milliliters. So I have my total volume right there. So that's looking good. Good. Now I know I'm going to have to convert to the 1.2 liters like I talked about. So in order to do that, I would do 1,200 divided by 1,000 to get 1.2 liters. I've got my total volume there. And then I would just finally multiply by 60 grams per liter. So times 60, ran out of room here. That's okay. Good. So at the end of it, once I multiply by 60, I would end up with 72 grams of protein. So 72 grams of protein per day provided from the tube feeding formula there. Good. Nice. Looks like Deborah's on it. Deborah's been studying their enteral nutrition quite a bit, it seems like, just this morning. So this is good, Deborah. We'll get to quiz you a little bit here. Okay. All right, everyone. So since you're all feeling good, let's go ahead and let's spend some more time on parenteral. Okay, parenteral time. And I'll keep a lookout for more questions as they come up. We're going to break this in two different segments. So the way we're going to break this up is we're going to go ahead and we're going to do the protein and dextrose. Those act the same, or we calculate them the exact same way. So I'm just going to leave those kind of the same group together here. And then on a separate slide, we're going to talk about how to do lipids. So let's talk through it here. So now parenteral, right, folks? Going in the IV, going in a central line. We're not using the GI tract in this case. So things are just a little bit different when it comes to this, as we know. So here's my kind of first step that I would say. The way that we're going to do dextrose and protein is this exact same. So follow one of these and just make sure you at least have that one down. So with this, what I would do first is when I'm given a question, let's say the question says, hey, Zach, the patient is getting, let's say, 500 milliliters of a 10% amino acid. Okay. AA, amino acid. So we're saying we're using a 500 milliliters of a 10% amino acid solution here. Okay. So that's what we're starting with here. What we would do is we would take that total volume of the protein solution. So again, that's going to be that 500 milliliters. And what you will do with that is you're going to take that 500 and you're going to multiply it by the protein concentration, okay? So the concentration is going to be that 10% or whatever they gave us in the question. Key point here, we need to multiply by a decimal. So you're not doing 500 times 10, you're doing 500 times 0.10. Okay, so 500 times 0.10. The nice thing about this is once you do that, It gives you the amount of grams of protein that is provided. And I think that's a nice simple step. They kind of make it easy for us there. It's hard to get there, it feels like, but once you do, you're like, hey, that totally makes sense. If I have 500 milliliters, then that would mean that if 10% of it is protein, then that would be 50 grams of protein that's provided right there. Period. So now I know how to find the total amount of protein that was provided in the parenteral nutrition solution. Good. Dextrose is a very similar, or in this case, it's the exact same way we did this here too. So with dextrose, let's do 100 milliliters of a 25% dextrose. Okay. So in that case, I would take my total volume of the dextrose solution, which was 100. I would multiply it times 0.25, not 25, but 0.25. Take that concentration and designate it as a decimal. When I would do 100 times 0.25, I know I should not have to do that calculator in my calculator, but gosh, I sometimes got to check my work. I will end up with the 25 grams of dextrose that is provided in that amount of solution. Okay? When it comes to proteins and amino acids, folks, right here is where it's at. You use this strategy every time that you're dealing with these types of questions for protein and protein and dextrose in that case. Now, what do we need to do after that? Key points to remember. If a question was asking how much total calories is provided from these nutrients, then here's what we would do. We would take our grams of dextrose that we talked about earlier. That was 50 grams. The grams of protein. Let's start with this one. So let's say I had 50 grams of protein that is being provided. I would take that 50 grams and multiply by the number of kcals per gram that is in protein, which we know from our very first class way back in the day. It would be 50 grams times 4 kcals per gram. Grams would cross themselves out, and that would be 200 kcals from the protein that's being provided there. Period. Just 200 kcals from the protein there. The dextrose is very similar with a small caveat here. You would take those grams of dextrose, the 25 grams of dextrose, and we're not going to multiply by 4. Regular carbohydrates like we eat all the time, is 4 kcals per gram. 4 once again. However, dextrose contains a little bit less calories per gram. It's actually 3.4 kcals per gram. So I do my 25 times 3.4 kcals per gram. Grams would cross themselves out. 25 times 3.4 would get you 85 kcals. Yep, 85 kcals from the dextrose. Correct, Priscilla. So those numbers are standard, right? 3.4 for dextrose and 4 for protein. Those are standard across the board for any of these parenteral nutrition calculations. They will not change, which is good. That's nice. Okay. So now we're going to pause for questions. Please post them in the chat if you have any. And remember, if you're feeling a little nervous or if you're like, I don't want to speak up and say that maybe I'm having difficulty, remember there's so many students just like you who are having probably the same exact question, the same exact difficulties. So please do not hesitate to speak out. The point of this session is to help you to know more about this. So use my time. Let's get through this together. Okay, we're looking good. Going to give that just a little more time, and then we're going to move on to some lipid action next. Lipids, lipids, lipids. Okay, so let's talk lipids, folks. For lipids, they're funky, they're weird, but they're very doable, extremely doable, actually. It just takes a little bit of tips and tricks. So, for lipids, with lipids, you do not go through the same steps that you did for protein and dextrose. You do not. You actually skip a step, technically. With lipids, we should not have to ever find the number of grams of lipid provided in a parenteral nutrition solution. Let me repeat that. You should not have to find the grams of lipid provided in a PN solution. On the exam, especially, I don't see you getting a question about grams of lipid from a parenteral nutrition solution. So that being said, here's what you have to remember about lipids is what's exactly in this box here. Ignore the propofol really quick, just if it helps you with this. So a 10% lipid solution, okay? So picture a little milliliter, a little droplet, okay? They all have different concentrations. So for this one, a 10% lipid is the only weirdest one, and that is going to be 1.1 calories in every milliliter. Pay attention to those units, folks. Calories per milliliter, not grams. 20% lipids are just a standard 2.0 kcals per milliliter. So that one's easy. 20%, 2.0. Seems really easy, right? 30% is also pretty easy. This is the highest concentration of lipids, at least that I've ever seen. I've never heard of a 40% or higher than 30. But with that, a 30% is going to be also 3.0 kcals per milliliter. So that's all you need to know for that one there. Propofol. I wanted to mention it here. I don't normally talk about propofol, but I thought it'd be good to add to this conversation. Propofol is a sedative. If you've ever worked in the ICU, propofol is used all the time to sedate patients. And it's in a lipid solution. Specifically, propofol is in a 10% lipid solution. So, what that means is you just treat it like a 10% solution. Um, so, yeah, just treat propofol like it's a 10%. It also is going to have 1.1 kcals per milliliter there. To solve these types of problems, the way you're going to do this is you will take the volume of lipids that they gave you in the question. So let's say I had 100 milliliters of lipids. And let's say for this example, it's let's say it's a 20% solution, which they told me. So by knowing it's a 20% solution, I know that it's going to be 2 kcals for every milliliter. Then all we have to do there is take 100 milliliters times 2 kcals per milliliter, leaving me only with kcals left over. So in this case, that would be 200 kcals from lipids that are provided there. Okay. All right, I feel like I'm going very fast, but it seems like everyone's doing really well. So what questions do you have for now? I'm going to keep an eye out for questions in the chat, but as I'm doing this, I'm going to expand this to kind of show you all this practice problem here, okay? So this practice problem says a patient is receiving 550 milliliters of a 10% lipid, should say solution there. How many total kcals are provided from lipids? So if you feel ready to go ahead and start on that one on your own, and then I'll catch up with you a little bit as we go through it. Oh, looking great on time. See what happens when I talk too fast? We have plenty of time after. So the way I would start this one is I would take my 550 milliliters. Yep, so to answer your question here, Priscilla, we convert it? Yes, you do. In a way, Priscilla, what you're doing is you're taking the percentage they gave you and you're just converting it to be kcals per milliliter that it's set up. So yes, 550 milliliters times a 10% lipid solution would mean it's 1.1 kcals per milliliter. Nice, nice, Becky. Way to be in the chat there and get that answer, and I definitely appreciate that. 550 times 1.1. I'm going to multiply those, and when I do, I'm going to end up with 605 kcals total from the lipids provided right there. So it would just be 605 kcals provided from the lipids there. Easy peasy. Okay. Good. All right, RDs to be. So are we feeling good on PN? And do you feel like you're ready for some practice questions? Because I'm really eager to go through some practice questions with you. You know, I'm big on practice questions. I want to see how you're all going to perform. So I say we dive right on into these to kind of wrap up our night a little bit here. And if you do have more questions, please don't hesitate to drop them into the chat at any point. It's totally fine to do. Good. 14 RDs to be in here. That's awesome. That's awesome. Good. All right, folks. So now let's do these questions here. Okay, so we're going to start with number one together as we kind of do this. I'm going to work through them kind of as we just to use our time. Normally, I would give you like, a minute to work on them on your own. But in this case, I'm going to go ahead and I'm going to start kind of chugging away at these to help you out a little bit. Let's zoom in just a little more to help make that nice and big because it's difficult to see, I know. Okay, so starting with number one, a patient requires 2,450 kcals per day. How much total volume would meet the patient's needs using a 1.5 kcal per milliliter formula? How much total volume? Total volume. Okay. Well, I know how to do this, right? If I'm starting with kcals of 2,450 kcals, I know that if I have a 1.5 kcal per milliliter formula, that I'm going to need to divide, right? I need to find the total volume, so I need to divide. Joanne, we are going to do a free water practice question. I didn't have time to do a whole slide on it, but we are going to do some free water here. Yep. So I will explain it. Yes, we will. So 2,450 kcals, I'm going to divide by 1.5 kcals per milliliter. Okay, so divide by 1.5 kcals per milliliter. And when I do that, I am only going to be left with volume. I'm only going to be left with that total volume, right? So I ended up with a total volume here of 1,634 milliliters. Okay. Now, everyone, this is really important, and I'm going to try to trick you. I love to try to trick you because I'm trying to make you better. This says how much total volume is needed. Does it say the rate? No, it does not. It does not say what does the rate need to be. So, in this case, what I would encourage you to do is say, what's the total volume you need to go with? Which in this case, answer B is the correct answer because it's asking for total volume. I want you to always be very careful about jumping on to the next step because that's what's going to burn you on exam day. So you should see if we did 2,450 divided by 1.5, I ended up with 1,634 milliliters for this. And Priscilla, yes, you can assume 24 hours, but just being very careful that they did not ask for the rate in this question. Not at all. They asked for the total volume, so I need to stop right here. I do not need to convert it to the rate in this case. But yes, you can assume 24 hours unless I say differently. Okay. So hopefully that's a good little warm up one for us to start with. Let's just keep kind of rolling through these and let's work up our progress doing these a bit. Okay, good. Now you should be able to see that there. Okay. And I'll keep an eye out for some questions if I need to swing back to these. Number two, a patient requires 2,000. Let's see. So to go back to you really quick, Priscilla. So you said, wait, I'm confused because I took each answer and multiplied by 24 and by 1.5. So Priscilla, what it seems like you're doing is you're working off of the answer choices. That is okay to do. But what I would say actually, Priscilla, is that let's calculate it the way I did. Let's calculate it as if we kind of know how to start this because think about it, when you have a patient, you're not going to have four rates to choose from. That's not going to be the case. So in that case, B is our best answer for that one. Let's look at number two together. A patient requires 2,750 kcals per day and is receiving a 2.0 kcal per milliliter formula. What rate would you recommend for the patient? So now remember, we have kcals. We're going to find our total volume, and then we're going to find the rate in each step here. 2,750 kcals. I'm going to divide that by the concentration. Remember, big number to small number. I'm going to divide that by 2 kcals per milliliter. When I divide those, I end up with what my total volume of the solution was, which was 1,375 milliliters there. Okay, so we have our total volume now that we're working with. Now we're going to find the rate. So to find the rate, I would take that 1,375 milliliters. I would divide that by 24 hours because I need to find out how many mils per hour there are. Hour. And when I do that final step, 1,375 divided by 24, I ended up with 57.3, but I'm going to round that up to 58. So let's say 58 milliliters per hour. Yep. Very good, Deborah. Nice, Joanne. Good, Priscilla. Very nice there. Very nice there. Yep. And remember, we wouldn't want to round down because then they're not going to meet their needs. If anything, I would round up just a little bit to that whole number for these. Looks good, RDs to be. You're looking great here. Looking really good on this question. Okay. Cool. I'm going to look out for more questions on number two if I see any on there. I'll leave that work up there. Actually, I'll leave that work there for just a minute or so. And we'll go on to number three as our next one here. So then that way, if you need to look at my work a little bit, you can do so. So let's look at number three together now. A little bit of a different one. We did not review free water today. We could always talk about it more during another session, but I'm going to just kind of explain it how I would to most of my interns or students. So how much free water is provided for a patient receiving a formula at 75 milliliters per hour? The formula is 70% free water. So what that means is if I have this big jug, okay, let's say this whole thing is just tube feeding formula. What we're saying is for the tube feeding formula, 70% of it is water. And that's usually the case. It's almost all water most of the time from a tube feeding formula. So what we'll do is we're going to first find that total volume, folks. Let's find that total volume and then find out how much free water that would be. 75 milliliters for every 1 hour. And I'm going to multiply to find that total volume. 24 hours. Hours are then eliminated to get me my total volume for the solution. And the total volume was 1,800 milliliters. So 1,800 milliliters, that's how much total volume the tube feeding solution is. Now, of that 1,800 milliliters, 70% of it is free water. So now I just need to take that 70% and multiply it here. So let's take 1,800 milliliters times 0.70. And that's going to tell me how much free water the patient is getting from the tube feeding solution per day. So that would be 1,260 milliliters of free water. Let me write that a little nicer. 1,260 mils H2O. You see that there. So that's a good example of how we find the free water provided. So it's not the calories, not anything like that. It's just how much free water is provided from the tube feeding solution there. Good. I'm going to keep an eye out for questions on that one, should anyone have any there. So Priscilla, how did I get 0.7? It's because of the 70% right here, okay? So they're going to give that to us very likely, yes. They're going to give it to us in the question because each tube feeding formula kind of varies on the amount of water it's provided. So when I did 70%, I'm multiplying it by a decimal. Remember, if it's in a percentage like that, I've got to multiply it by a decimal. So instead of it being 70%, it's going to be 0.70 there. Okay, good. All right, going to leave that one up too if you just want to make some more notes on that. Now let's do a parenteral nutrition question a little bit. Let's do some PN, huh? So, how many kcals from protein is provided from a TPN solution that is 500 milliliters of dextrose, 25%, 300 milliliters of amino acid, 15%, 100 milliliters of lipid, 10%. Okay, so start working on that a little bit. Joanne, I think the test should give you the percent free water for the formula because each formula, depending on the formula company, depending on the type, they might have a small variation in the percentage of free water. So they should give you the 70% in that case. For number 4, how many kcals from protein? From protein. Read the question, folks. Read the question. Push up a little more? Absolutely. Good. Oh, I see what you mean. I'm so sorry about that, Lorianne. Thank you. I see what you mean. Thank you. Got you. Let's do it a little more. That way I know it's coming into you. Okay. So how many kcals from protein is provided from the TPN solution there? So with that, I've got the dextrose, amino acid, and lipids. But the question is specifying how many kcals from protein. So guess what? Dextrose, don't need to use it. Lipids, don't need to use it. Okay? Do not mix yourself up. Do not make extra work for yourself when you do not need it. It's not necessary. I've taught you how you need to approach a protein type of question here. So let's take our 300 milliliters, the total volume of that protein solution, and then we are going to multiply it by the concentration, right? The concentration in this case is 15%, so times 0.15. When I do that, I'm going to end up with the total number of grams of protein. Grams of protein. I want to take this pause just to remind you, if you struggle with PN, you see how I'm always writing my units as I go through? I still do this to this day, and I can do these pretty much blind at this point, but I still write my units because I can get mixed up. And on the exam, we don't need to get mixed up. Let's just track those units as we go. 45 grams of protein. How many kcals? Well, I'm going to do, I'm going to do times 4 kcals for every 1 gram. And I'm going to cross those out. And I should end up with 45 times 4, 180 kcals right there. Or answer C. Good, good. Yep, and Becky, you're doing good there. You caught yourself. That's what we need to do. If we catch ourselves just doing something wrong, or if we had one unit off a little bit, that's okay. That's why we just need to check our work all the time and make sure. Nice, Joanne. Good answer there. Very nice. Very nice. Okay, folks. So the PN was a little harder, right? Just a little harder than the Enteral, we know. We don't do it as much in our dietetic internship, and it's just a little more foreign. So, yeah, it can be challenging a little bit there, but with practice, we're going to get better and better at these. Let's do number 5 together now. Okay, hopefully I'll give you all your answers so you can see them all in this case. Let me zoom in a little bit there. Let's see how that looks. So for number 5, it says how many total kcals is provided from the following TPN solution. So I have 1,000 milliliters of 25% dextrose, 1,000 milliliters of amino acid 10%, and 500 milliliters of lipid 20%. So let's go through these together. We're going to do each of them and find the kcals provided for each of them, and then we're going to add them all up at the end. So let's start with dextrose. 1,000 milliliters times 0.25. That tells me that I'm going to get 250 grams of dextrose. We know that's going to be the case there. 250 grams of dextrose. I'm going to take those 250 grams times 3.4 kcal for every 1 gram. And when I do that, 250 times 3.4, remember we do 3.4 for dextrose, not 4. I'm going to end up with 850 kcals. I can write that a little nicer, Zach. 850. Okay. Now let's do the same with our amino acids. 1,000 milliliters times 0.10 is going to be equal to 100 grams of protein times 4 kcals per gram is going to be 400 kcals just from the protein there. 400 kcals we got for that one. Now let's do our lipids. 500 milliliters of a lipid 20%. So say it with me, lipid 20%, that means it's going to be how many kcals per milliliter? How many kcals per milliliter? That's right, 2 kcals per milliliter for a 20% lipid. So 500 milliliters times 2 kcals per milliliter. Milliliters will be crossed out, and I have 1,000 kcals from that. So finally, all we have to do, 850 from the dextrose, 400 from the amino acid, and 1,000 from the lipids there. When I add all those up, I ended up with 2,250 kcals right there. And by the way, I do recommend kind of going through it in that way. Just get through all of your dextrose, find your kcals, get through all of your amino acid, find your kcals, then do your lipids. That way you just keep everything nice and straight. Could you do this without using your whiteboard and scratch paper? No, I don't think you should do this on the exam without a whiteboard, a scratch paper, or something to write this down, because you can't expect yourself to remember each of these values each time. Just write them down, get them on a board, make it easier for yourself there. Okay. Okay. Looking good. All right, it's pretty quiet in the chat. So here's what we're going to do. We're almost at the top of the hour, but we're going to go a bit longer. I have 5 more questions for you. And these 5 are going to be a little bit more advanced than what we just did today. So if you feel confused, maybe hop off now and come back to this a little later. But if you feel ready for it, let's do 5 advanced questions on EN and PN to kind of wrap up our night a little bit here, since you're all doing really well. Okay. Yeah, so Priscilla, remember Priscilla, so with the lipids, we're not doing it the same way. With lipids, 20% would mean 2 kcals per milliliter. Remember, lipids is different than what we did for dextrose and amino acid. Very understandable question there. Good. Okay. All right, everyone. So let's do 5 more advanced questions together. I'm going to move it just a good rate so we all keep our time nice and in check tonight a little bit here, too. Okay. Let's do it. Starting with number 6 here, let's get a little bit more advanced, What rate would you, oh my gosh, sorry about that, folks. That's so annoying. Okay. What rate would you recommend for a patient who requires 2,500 kcals per day and 140 grams of protein daily? Formula used contains 1.5 kcals per milliliter and 84 grams of protein per liter. Let's do it. I'm going to start with the kcals themselves. So I have 2,500 kcals. I'm using a 1.5 kcal per mil formula, so I'm going to divide that. I want to find out what the total volume would be. Divided by 1.5. When I do that, I'm going to end up with 1666.6. I'm basically going to end up with 1,667 milliliters there. Okay. Now I want to pause here really quick. We're gonna find the rate here in a minute. But here's one thing I might recommend you do. I would say we know that this amount of milliliters, this amount of formula, it's going to meet their calorie needs. We know that already because we just did this division here. We do not know, however, if it's going to meet their protein needs. So I would encourage you to check that. Is it going to meet their protein needs? How do we find the protein needs again? Well, we would do our milliliters of our volume and we would convert it to liters. The reason being, remember, protein is provided in grams of protein per liter. So you need to get everything on liters to check this. And you could do this at the end too. It's totally up to you if you wanted to, but I don't know. I like to check it now and see. So if I wanted to check the protein, I would convert this to liters. So 1,667 divided by 1,000, because we're trying to go from milliliters to liters here. Milliliters to liters. When I convert that, I ended up with 1.667 liters. Now I've got it in liters. I know that protein is given in grams per liter. So let's check that. 1.667 times 84 grams per liter. When I do that, it looks like the patient is going to get about 140 grams on the dot of protein. That's exactly how much they need per day. So we are in good shape. We are good to go on the protein. We are good to proceed to find the rate for this patient. So finally, if I wanted to find the rate, let's just go back up here to our total volume. I'm going to take that total volume, if I figure out my life here. I'm going to take that total volume of 1,667 and I'm going to divide that by 24 hours. And I'm going to end up with a rate of 69.45. I would say my best answer will be A. I don't want to do a lower number because then we're going to give them less than what we need, and we do not want that to be the case. So this is how I'd recommend approaching a question that's asking for protein and the amount of calories too. If you just stopped at the kcals, that's a mistake, okay? We have to check the protein, especially in practice, because just because you meet their calorie needs doesn't mean you met your protein needs. A lot of the times you have to play with your formulas and play with your numbers to meet a patient's protein needs. So, milliliters per hour. Good. All right. Good, good. Just for sake of time, we're going to move on to our next one here. It's going to take us just a few extra minutes here. I'll leave the work on that one up there so you can still see it for a few minutes. Okay, good. So for number 7, a patient, this is going to be another free water question, and it's going to be a little longer, but I want you just to pay attention closely to what I'm doing here. A patient is receiving 5 boluses per day. Each bolus is 240 milliliters. They're using a 1.2 kcal per milliliter formula, and the patient requires 2,500 milliliters of free water per day. So, how much water do we, you, me, the patient? We need 2,500 milliliters of just water. We're not talking formula here, we're just saying pure H2O, pure water. The formula itself, though, does have water in it. It's just not all water. So the formula contains 80% free water. How much additional fluid should the patient get outside of what's provided in the tube feeding? So here's what you need to do. You're going to need to find out how much total volume they're getting per day from the formula. Then you need to find out how much free water is going to be in that amount of formula. And then finally, you need to say, okay, if they're getting this much from formula, how much extra should I give them to meet their needs of 2,500 milliliters? Just like that. So here's what I would do. Start with your bolus, and let's find your total volume of formula. You have 5 bolus, and you're going to multiply by 240 mils for each bolus. That's going to give you your total amount of formula that's provided per day. In this case, that's 1,200 milliliters from the formula, not water. This is just the total volume of the formula itself. Then I want you to take that 1,200 milliliters, and since it's an 80% free water solution, what you're going to do is you're going to multiply that by 0.80. That's going to tell you how much free water is being provided to the patient. So with that, if I do 1200 times 0.80, they are getting 960. I'm going to put this in blue. 960 mils of H2O just from this tube feeding solution. That's all they're getting there. But in a day, they need to get 2,500 mils. So now let's do this. 2,500 mils minus what they're already getting from the tube feeding solution minus 960 will tell you that they need to get an additional 1,540 mils of H2O per day. This is what they need outside of the tube feeding solution. This means our best answer is going to be answer D. That's how much extra water they're going to need per day. So that one's a nice little, I would call that an advanced question just because it has a lot of extra steps. You got to deal with boluses, you got to deal with finding the difference of free water. And just to add in here, folks, the exam is going to do things to try to throw you off. For instance, I threw in here 1.2 kcals per milliliter. You did not need that at all for this question, not at all. But many students will try to bring something in because they were given it. Remember, don't fall into that trap. That's what it is. It's a trap. Pay attention to what it's asking for in the question and just focus on that. Good one there, folks. Good job. Okay. Just a couple more here. Number 8, this one's going to take us just a few extra minutes too, just because I know you've all seen a question like this probably before. It might have been a while for you, but I want to kind of explain this. So with parenteral nutrition problems, there's a couple ways they can present it to you. More than likely, the way you're going to get it is the way we've already seen, where you're given the total amount of dextrose, the total amount of amino acid, the total amount of lipid provided. But there are times where a question might be like this, where they have given us a TPN solution that is mixed in a liter, okay? Mixed in a liter. So what we're saying is we have like this whole liter here, and they're saying that they have broken it up that 500 milliliters of it is dextrose 20%, 250 milliliters of it, that's going to be lipid 20%, and the other 250 milliliters is amino acid 15%. So like picture this thing is already pre-mixed already, and now we're being given a rate. So they're saying now, if they give us this rate, how much total kcals are they getting per day at this rate? So here's the first thing that I would recommend, because these ones can be just a little tricky. They always were for me. But again, comes back to find the total volume, okay? The total volume would be the rate times 24 hours. 50 mils per hour times 24 hours tells you that in total, no matter what, they're going to get a total of 1,200 milliliters per day. Now, I want you to just hold that in the back seat for right now, okay? Here's how I would recommend kind of going about this next step. What I would say the easiest way to go about it is all of these are given milliliters. But what I would say is maybe focus on finding it how much calories is provided for each of these. So here's how I'm going to put it here. For the dextrose 20%, I'm going to proceed normally how I would. 500 times 0.20. 500 times 0.20 is going to be 100 grams of dextrose times 3.4 is going to be 340 kcals. Okay. Now, pay attention to this. This is where it can get really tricky. I'm going to say this is kcals per liter. Okay. The reason I'm going to do that, and I know that's really confusing, is because this in total, this is 1 liter right here. All of these added up is 1 liter. What I'm trying to get you to kind of understand here is if we're just looking at the dextrose, this 500 mils of dextrose, every liter I use, there's 340 kcals from dextrose. So if I do 2, 3, 4 liters, whatever it is, I now know that there's 340 kcals for every 1 liter. And I want to do the same for each of these. I'm going to do the amino acids really quick. I'm going to jump to that. 250 milliliters times 0.15 will be 37.5 grams times 4 kcals per gram times 4 is going to be 150 kcals. And again, I'm going to say per liter, per liter here because it's all mixed into this liter. Same with my lipids, but remember, we're going to approach it how we know we need to do lipids here. Lipids would just be 250 mils times 2 kcals per mil, and that's going to get me 500 kcals per liter. Okay, per liter. Again, normally we wouldn't really do it this way. It's just because when we were given the rate, it gets a little bit confusing. So now, I'm going to do all these together. So 340 plus 500 plus 150 means there's going to be 990 kcals in this whole liter. So in this liter, in this whole container I have here, we're saying there's 990 kcals in that liter. Hopefully you're all with me so far. We know that in total, because when we calculated the rate, there's 1200 milliliters total, which I'm going to skip a step here. 1200 milliliters is the same as 1.2 liters. So volume, 1.2 liters. That's how much total solution they're getting in a day with this rate. So I'm going to do 1.2 liters times 990 kcals per liter. Liters get crossed out. And then finally, what I'm left with is how much kcals is provided in 1.2 liters. So if I do 1.2 times 990, I'm going to come up with 1,188 kcals, which brings me to answer B as my best fit for that one there. That's probably the most advanced question that we will do, is going to be a question like that. And when I was studying for this exam, I struggled really greatly with this concept here. What I would recommend, if you're still really confused, let it digest a little bit. Let it digest and maybe come back to this video and rewatch this part and see how I went through that. Just because I think there's a few different ways you can go about it, but this has been the way that I think it's been best to approach these here. Okay. Well, a little bit of a trickier one, but one that I wanted to present to you because gosh, it's tough. All right. Good. So while you're letting that digest, let's end with a little palate cleanser. Yeah, what's it's asking, of course, Priscilla. So let's do a little palate cleanser to finish our night. I've got one more. We're going to take a pause on number 10. So for now, number 10 is going to just take a back seat tonight, just for sake of all of our time. I will follow up on that question in the future again, but let's do our palate cleanser a little bit with number 9. just to finish our night together here nice and strong. A patient is sedated using propofol, or they're receiving propofol at 18 milliliters per hour, and they're also receiving dextrose 5% at 80 milliliters per hour. How many total kcals are provided per day from propofol and dextrose? So with this one, propofol, I told you propofol is a sedative. It's a very good one, does a very good job. And propofol is going to be in a 10% lipid. So we just treat it like a 10% lipid, folks. If I have 18 milliliters per hour, I'm going to multiply by 24 hours. And when I do that, I end up with 432 milliliters. 432, write that better, Zach, milliliters here. Then I would proceed like I would for all other lipid questions, right? So I would take the 432 milliliters times 1.1 kcal for every 1 milliliter. Milliliters cross themselves out. 432 times 1.1 is going to be 475, let's just leave it at that, kcals. Then let's go ahead and let's go to the next one of dextrose. So with dextrose, we have 80 milliliters per hour using a 5% solution. I'm just going to write 5% here. So let's do 80 mils for every 1 hour. I'm going to multiply by 24 hours. That's going to get me my total volume just from the dextrose. Make sure we pay attention to that. So it'd be 1,920 mils from the dextrose. And then we're going to do how we proceed forward with the rest of these. So 1,920 mils of the dextrose times the solution. It's not going to be 0.50, it's a 5%. So remember, move that decimal place over 2 points times 0.05. 0.05. And when you do that, you are then going to be left with the number of, sorry, I'm trying to talk and do things at the same time. We're going to be left with the grams of dextrose there. So 96 grams of dextrose. And then finally 96 grams times 3.4 kcals per gram is going to get you a total of 326 kcals. Sorry, I'm running out of room here. So then finally, folks, let's get my big dome out of the way here. So then finally, folks, what we'll do is let's take that 475, that 326. It originally had asked for us to say how many total kcals is going to be provided. And when we add those two up, oh, I ended up with just a little bit of a different number. Maybe I did something a little wrong there. Let me see. 24, 432 times 1.1, 475. Okay, that's good. Sorry, folks, just want to check my work here because I got maybe just something a little different than what I had in my answers, but that's okay. That's right. Okay. Well, my answers weren't correct in there, but when I add up my 475 and my 326 together, I should end up with, oh my gosh, I should end up with a total of 801 kcals, when we add those up. So let's just put this as 800 kcals is what I meant there, not 860. That's not what you saw there. So when I added up those two answers together, just to get the calories from the propofol and the calories from the dextrose, I ended up with answer A, which was my closest one, of 800 kcals. I ended up with 801, but 800 fit pretty well right there. Mm-hmm. Exactly. So it was always 800 there. It was never 860 on there. What do you mean? So it looks like A will be our best fit for that one there. All right. Awesome. And a note from Deborah here. The session is literally the closest that Deborah's seen to questions that were actually on the exam. I really appreciate that, Deborah. That's quite the compliment to me because I try to make sure these questions are going to be difficult, going to prepare you from the simplest of EN to the hardest of PN. I want to make sure that we're prepared in every way possible when it comes to these. All right, everyone. Is there any final questions before we leave tonight? And hopefully you felt like things went a lot smoother tonight compared to some other streams on there. Yeah, absolutely, everyone. So let me pull that back up. All right. Well, I will let you all go, let your all brain just absorb everything. Thank you so much for joining this RD Exam Ready Live. Please remember to check out the podcast, like, subscribe to the channel, check me out on Instagram, and reach out to me if you have any questions. But as always, I always sign off to tell you, happy studying to you, RD to be. Make sure you just keep working hard and reach out with any help that you might need.